Good afternoon. Today I'll be presenting the work on financial sentiment analysis in a South African landscape. In the first part, I'll give a short introduction to the topic, highlight the motivation for the study, and formulate the research objectives. I will then briefly discuss some literature related to the study, and thereafter present the methodology and results. To close off, I'll review the conclusions and highlight the contributions of the study and areas for future work. Big organizations produce large amounts of textual information through their own official communication, which further leads to even more information being produced through online platforms. These impact on the market perception, which in turn impacts on reputation. One of the industry-accepted measures of reputation is the RepTrak score, which takes into account 7 drivers of reputation. The performance driver can be seen as a measure of the financial health of an organization. In the past, historic accounting information formed the basis for predicting financial performance using statistical models and advancing to more sophisticated machine learning models. Subsequent research started using qualitative measures such as textual analysis to predict performance. The justification for this study is rooted firstly in the evidence that there is a financial value linked to the reputation of an organization. It can improve the company bottom line by as much as 6%. The focus of this study is on the performance driver as one of the measures of reputation. The goal is to measure and understand the sentiment of finance-related communication and its impact on financial performance. A second motivation for the study stems from identifying a gap with regards to the use of NLP for financial sentiment analysis on South African data. This is evident from the lack of available research in this area. Even though existing sentiment analyzers are freely available, they were developed within a given context and relevant for a specific domain and geographical area. Therefore, based on this motivation, 3 research questions were identified. The main question is, what NLP techniques are required to successfully determine the sentiment of financial communication in a South African context? From this, 2 additional questions were posed. Firstly, is there a correlation between the sentiment of financial news and company performance as indicated by share price? And secondly, how effectively can a narrower sentiment prediction model be applied to a broader scope of finance-related information? In other words, how well does the model generalize? These are some of the most popular categories of general sentiment analysis techniques. Firstly, there is open source pre-trained sentiment analyzers. Examples are TextBlob and Vader. Both these are rule-based analyzers, and the outcome is a value between -1 and 1, denoting a scale from negative to positive. Another technique is a simple dictionary-based approach. This method typically uses a dictionary of words or phrases either manually created or automatically generated. In the finance domain, a popular dictionary is the Lothar & McDonald Sentiment Word Lists. These were developed to overcome the fact that more general dictionaries often misclassify financial texts. The last approach is custom-built predictive models using machine learning. This involves either using traditional models such as logistic regression and support vector machines or deep learning models. These are supervised machine learning models and require labeled data sets. One of the tasks during the 2017 Semantic Evaluation Conference was fine-grained sentiment analysis on financial microblogs and news. In this table, a few of the approaches and results are given. The use of deep learning models showed a 5% improvement when compared with more traditional machine learning models, indicating that the latter can successfully be used to set a baseline for further improvement. This schematic shows the overall design to answer the 3 research questions. The first step was data collection, cleanup, and processing. For purposes of model development, various sources of publicly available textual data from a South African petrochemical company was identified. The most relevant were non-official communication in the form of online news and stock exchange news service reports. Topic modeling was then used to filter the data to specifically extract finance-related documents. This was done based on full article content. The model used non-negative matrix factorization with input vectors generated using TF-IDF. From this model, the dataset reduced to 808 financial documents. 4 independent annotators could therefore label the full dataset due to its small size. The majority label was used as the ground truth. This table shows the distribution of labels. The next step was developing the prediction model. It was decided to only use the document headlines for this. For developing the sentiment prediction model, the approaches mentioned earlier were implemented and compared. That is, the pre-trained analyzers, custom-built prediction models, and a simple lexicon-based approach. As was shown, the Lothar-McDonald sentiment word lists only contain sentiment-carrying words, and therefore, in order to compare the various approaches, documents with a ground truth sentiment of neutral were excluded. The resulting dataset contained 668 documents. Firstly, for evaluating existing analyzers, TextBlob and Vader were used. Results are subpar with accuracies of only 19% and 51% respectively. Secondly, as you will recall, the main research objective was to predict the sentiment of financial text. In other words, annotate user-generated content. It was therefore decided to first focus on traditional machine learning by developing a binary classifier with XGBoost. Further pre-processing on headlines were required, such as removal of stop words and punctuation. Input features are word vectors derived using TF-IDF. The dataset was split 80-20 for training and validation. A 10-fold cross-validation accuracy was 81% with a standard deviation of 4%. The validation accuracy was also 81%. Here are the top most important features from the model. As you can see, the words are relevant to financial sentiment. To compare with the results from the pre-trained analyzers on the left, the accuracy on the full dataset was calculated to be 94%. For the dictionary-based approach, the analysis was done in 3 phases. For experiment 1, the base dictionary as updated in 2018 was used. For experiment 2, synonyms for the words in the lists were added. And for experiment 3, which was similar to experiment 2, except with the addition of synonyms for words in the modal lists. Also, due to the small size of the dataset, the results could be manually inspected and words added and deleted accordingly to create the final dictionary. In the next section, I will explain the concept of a hinge structure that was implemented for these experiments. Typical hinge words are as, but, amid, after, ahead, while, and despite. The premise is that the hinge splits the sentence into 2 parts, both parts carrying the same sentiment. If one therefore determines the sentiment of the first part of the sentence, the overall sentiment is inferred. These 2 example sentences show that it isn't always the case. However, for this model, it is assumed that the sentiment is only dependent on the part before the hinge. It was also found that a comma is often used as a hinge in financial headlines and was also considered. Alternatively, the full headline was used. Words were lemmatized using adjectives, verbs, and nouns to ensure maximum chance of matching words in the dictionary. Recall that there are sentiments in the dictionary such as uncertainty and constraining, but that was not considered in this round. Therefore, in the case where multiple sentiment-carrying words were present, the first occurring positive or negative word was used as the sentiment of the headline. Where there was no match, it was labeled as not detected. After implementing this method, the results were as follows. For experiment 1, the accuracy was only 37%. For experiment 2, it increased to 67%. And in the last experiment, it further increased to 84%. The new dictionary is more than double in size, and only the words break, closed, closing, and despite were removed from the original lists. To summarize the results, some other performance metrics were calculated. From these results, it can be seen that a traditional machine learning model performs best for this task and is recommended to be used for sentiment correlation with financial performance. This next section will address the first sub-research question. In order to answer whether there is a noticeable trend between sentiment and share price, a time frame of 6 months was used. Periods A and B are periods where sentiment improved and was reflected by an increase in share price. Similarly, period C stands out through a significant amount of negative sentiments and a severe drop in share price. These results show promise that there are indeed periods where sentiment and share price correlate well. This last section aims to address the second sub-research question. To determine how well the model generalizes, data from a similar sized company, also in the energy sector, was collected, cleaned, and pre-processed. Topic modeling was used to filter for finance-related documents. The sentiment was predicted on the headlines using the updated dictionary as well as the developed XGBoost model. This table shows a comparison between the predictions. From this, it seems that the XGBoost classifier is more biased towards negative sentiments. There is only a 52% agreement between the two models. Since there is no ground truth sentiment labels for the data, it was decided to manually evaluate the predicted sentiments to provide a more informed view. It was observed that the sentiments predicted from the dictionary were more accurate. On further inspection, it was found that only 29% of the words in the new dataset exist in the vocabulary from the pre-trained XGBoost model, explaining the lower confidence. Therefore, increasing the size of the data set used for model development may improve overall generalization. The last part of evaluating model generalization was to observe whether there is a correlation between predicted sentiment and share price movement. For this, the dictionary-based approach was used. Some correlation is observed, however the dataset is small. Data over a longer period should help with a more informed view. Here with the conclusions on addressing the research objectives. Firstly, it was determined that NLP techniques can be used to successfully predict the sentiment of financial articles in the South African context. It was shown that dictionary-based approaches and traditional machine learning models performed well and set a baseline for further improvement. Secondly, analysis showed promising correlating predicted sentiment and financial performance as represented by share price, and with refinement can be used to identify at-risk periods for an organization. Lastly, the model didn't generalize as well as expected. Dictionary-based predictions were more accurate than the XGBoost model, mostly as a result of the size of the developed vocabulary. Increasing the size of the dataset used during model development should therefore improve generalization. The main contributions of this study are as follows: the development of an updated sentiment dictionary suitable for financial articles, setting the foundation for expanding the work to include a broader sentiment prediction model that takes into account various topics, and lastly, making progress towards an open source library for financial sentiment analysis developed on South African data. To conclude, here with a summary of the recommendations for future work. Firstly, to develop a more sophisticated, streamlined process to update or expand the new dataset. To improve the model generalization capability by increasing the size of the training dataset. Publish an open source financial sentiment analysis tool or library that can be used on South African data. And then lastly, to evaluate the performance of deep learning models. A recent study overlapping the period of this study showed that transformers outperform all other models and therefore will be considered in future work.